So, welcome to part two of the planets lecture. Where we left off, we had just talked about the four inner planets, known as the terrestrial planets, or Earth-like planets. And as we move further from the sun and we get away from Mars, we pass through the asteroid belt. And on the other side of that asteroid belt is our first outer planet, and it is Jupiter. And so we are now moving into the outer planets. The outer planets are known collectively as the gas giants, but they consist of Jupiter, Saturn, Uranus, and Neptune. No longer really technically a planet is Pluto and its moon Charon. Pluto is now a dwarf planet, but still a fan of it, although we will focus our time on the four outer planets. The outer planets are known as Jovian planets. Jovian means Jupiter-like. They are all gaseous, as mentioned before, meaning they are composed of gas, and that gas is primarily hydrogen. So hydrogen, if we recall, is the most common element in the solar system. It was also the first element formed after the Big Bang. It is the simplest. It is everywhere, and it makes sense that these planets further away from the sun actually consist primarily of it. So we will focus on that as one of our main takeaways. We will begin with Jupiter. Jupiter, the largest planet in the solar system, unique in that it contains this massive hurricane, which we'll talk about in a moment. But first, some facts. Jupiter is 88,650 miles across. As a quick comparison, Earth is only about 8,000, so Jupiter, a very comfortable 10 times the size. However, it spins very, very quickly, so it rotates on its axis every 10 hours. And so that is very, very fast, especially considering its size. Although, due to its distance from the sun, it takes 11.9 years to get around it. And so that takes quite a while. Also, due to its distance from the sun, it is cold. It's far away from our heat source. So it is a rather cool negative 230 degrees Fahrenheit on average. As mentioned earlier, it is a gas giant. Its atmosphere and itself is 90% hydrogen. It does have moons, lots of them, and we will talk about more of these moons, but there's at least 28 of them. Some interesting facts. The red spot on Jupiter is just a massive storm with sustained 400 miles per hour rings, 400 mile per hour winds. Jupiter also has some very thin rings that orbit around it. It is thought to have a molten metal core. It is named after the king of the gods. And in the 1970s, we've actually had some satellites pass Jupiter and collect some information. That was Pioneer and Voyager. Let's take a look at Jupiter when compared to Earth. Earth's looking pretty puny. In fact, 3 of us could fit inside of this red spot. That is how large Jupiter is, but it is beautiful. As we move further from the sun, we next encounter our next gas giant, and that is Saturn. Saturn is unique and well known for its large rings that orbit around it. Also very, very attractive and widely considered the most beautiful planet in the solar system. Let's look at some facts. Saturn's about 74,900 miles across, so pretty darn big. Not quite as big as Jupiter, but very, very large. It also spins very, very quickly. So it rotates, it only takes 10.6 hours to rotate completely, much, much shorter than an Earth day. But it takes 29 and a half years to get around the sun. It takes a long, long time. It is cold and windy. It is very, very far away from the sun, further than Jupiter, obviously. And so it's very cold. But because of how quickly it spins or rotates, it can sustain 1,100 mile an hour winds. In fact, these are the fastest winds in the solar system. It is a gas giant. 96% of it is hydrogen. Like Jupiter, it has lots of moons. It has at least 18. Some of them are very well known, like Titan, Rhea, and Lapidus. It is neat in that it is the only planet with a density less than 1, meaning that if you had a bathtub large enough, Saturn could actually float in it. Other neat facts is the fact that the Cassini space probe orbits around it and collects information. And we will hopefully talk about more of the Cassini mission when we get into space exploration. So that is Saturn. Again, much, much larger than Earth, especially when we compare them side by side. A gas giant. So now we move further away, and we finally get to Uranus. Uranus, notice, has some beautiful rings. It's kind of a pale blue color. It is very gassy. Some quick facts. So smaller than Jupiter and Saturn, but still much, much larger than Earth. Remember, Earth is about 8,000 miles across. Uranus, 31,765 miles across. Still rotating quickly, however, because of its gas composition. It rotates in only 18 hours. So again, much, much shorter than a day on Earth. However, it takes 84 years to get all the way around the sun. Again, it's much, much further away from the sun than even Saturn is. And because it's so far away, it's really, really cold. So Uranus is cold. We're talking negative 357 degrees Fahrenheit. Not a friendly place to be, Uranus. Composition, gas, obviously. And those gases, hydrogen, helium, and methane, which cause that planet to be a beautiful blue color. So Uranus is gassy, it's blue, it's really, really cold, it's really, really far away from the sun. Also, it has moons. It has about 21 moons that orbit it. Some interesting facts. It actually orbits in a sideways direction, where everything else is kind of on a singular plane. Uranus actually orbits sideways, and it has those 11 faint rings. So that is all you really need to know about Uranus. A quick reminder, if you miss anything I say, you can always pause the video to take down the important facts that need to be on your card. Comparison of the size of Earth to Uranus. Again, Uranus is a little smaller than Jupiter or Saturn, but still is pretty gosh darn big and is much, much larger than Earth. And finally, we come to Neptune, a deeper blue, very, very beautiful, very, very far away from the sun. Neptune, similar size to Uranus, 30,779 miles across. Again, very, very fast rotator, spinning 16 hours all the way around, much, much shorter than an Earth day. But look at that, 164 years to get all the way around the sun. That is one long year. It has very strong winds due to its rotation. It is also very cold. Average is negative 360 degrees Fahrenheit. Like Uranus, it is made up of gas. Hydrogen, helium, and methane. Again, that methane is contributing to its blue color. It has 8 moons. It also, because of how quickly it is rotating, sustains and has been measured as the fastest winds in the solar system, a little over 1,200 miles an hour. 1,200 miles an hour being a little bit faster than the sustained winds on Saturn. If we jump back to Saturn quickly, Saturn spins very, very quickly, faster than Uranus, but is so big that it doesn't sustain quite as fast of winds. And so where Saturn has been measured at 1,100 miles an hour, Neptune has been measured the fastest, 1,200 miles an hour. Not unlike Jupiter, it also has a very large storm, but instead of the red spot, we call it a great dark spot, as nowhere near as large as Jupiter's storm. And again, this gas giant has rings. Here's a size comparison. Again, much larger than Earth. These gas giants are big. In fact, Jupiter would only have to be about 10 times its size to be considered a star, or actually start fusing hydrogen. But because it is not, it ends up just being the largest planet in the solar system. A very cool fact about Neptune, it has ice volcanoes on its surface. Hopefully we'll get a chance to talk a little bit more about that in class. So here again is a zoomed out version of the orbits, obviously to scale, so you can't even see or read the inner planets. And when we get outside the asteroid belt, you can see Jupiter, Saturn, Uranus, Neptune, and then our dwarf planet Pluto, which does not really orbit on the same plane as the rest. We will play this quiz in class, but first I want to show you just how fast in real time and also in sped up time all of the orbits work together with that simulator. So here, now we have a zoomed out version of our solar system, and we'll play with this more in class, but I can zoom in to just the terrestrial planets. I can zoom out and include Jupiter and Saturn and Uranus and Neptune, and I can play these all at once. And if I did it at the actual time, at the actual speed, you wouldn't really see much moving. But if I sped it up a little bit at a time, you'll see that terrestrial planets get around the sun pretty quickly. Mercury obviously is the fastest, with Venus falling behind, then Earth, and then Mars taking its sweet time. But man, if we compare it to how slowly it takes for these Jovian planets, or the gas giants, to get around, it takes much, much longer. So Jupiter's moving okay, Saturn's hardly there, you can hardly tell Uranus is moving. Neptune, again, can't even see. But if we speed it up, then we get a good sense of the comparison. And so now we see all of our planets moving. Mercury and Earth, Venus and Mars are really cooking. Look at how long it takes for things like Uranus and Neptune to get around the sun. Very slow, very plodding. Also, as a bonus here, we have our friend Pluto, which has a little bit more of what we would know as an elliptical orbit, not quite as circular. We also have another exoplanet called Makemake out here, and another one called Eris and Haumea. We'll explore a little of those, hopefully. But these are other identified dwarf planets, planetoids, in our solar system. All I'm holding you guys accountable is for the planets themselves. And we'll play with this on our own time. I just wanted you to see quickly the difference between how quickly these planets rotate the sun, rotate around the sun. So that concludes the gas giants.